Good morning to all.
Morning, sir.
Good
Sir?
morning. Good morning, Anushka. Good morning, David. Miracle. Good morning. Edric. Good morning.
Good morning,
Everyone,
sir.
tell the camera.
Sir, sir, is this chapter small or big?
This is big.
So that means it'll take till Tuesday to finish this.
Maybe. Okay. So now we learn about the reactivity series. It means that the higher reactivity metal will displace the lower reactivity metal from its compound. That we learn. Yes or no? So for you guys, I will upload reactivity series so that we can remember it. This is the activity series in which we can see that like potassium is there. So potassium can displace sodium from its compound. Zinc can displace iron from its compound. But can iron can displace zinc?
No,
No,
sir.
because iron is lower reactivity as compared to zinc. Got it, guys? Yes or no? Now we will see this thing. So we have here in the test tube there are three types of like three test tubes are there, and in three test tubes iron nail is there. So from A and from B we can conclude that A is rusting. Why? As I told you, rusting can only be done by water. No. Rusting can only be done by oxygen. No, both are needed. So in the A test tube you can check that like water as well as air is there, which makes the iron nail to rust. Now B part, you can see that
Sir,
the yes,
water and oxygen is both needed to make rustin, right?
yeah, okay. In the B, where iron nail is fully immersed in water, it is not rusting or it is rusting a very little bit. It is not rusting or rusting a very little bit. Why? Because the fully water is there. There is no air in it. Okay. And the C part, calcium chloride. Calcium chloride is the salt which absorb the moisture. There is no moisture and there is only air. Okay. So it means that C will also the iron nail will not rust. Did you understand, guys? No. So do you from the above activity it is clear that rusting needs both oxygen and moisture. Now, can you tell what you generally do to prevent your bicycle from or wheels or iron gate in your garden from rusting? How will you can prevent from the rusting? We have different
So put
points.
oil.
Put
Painting.
oil or painting, oiling, galvanization. Now, what is galvanization? Galvanization is the process in which, like for example, if this is an iron, like for example, if this is an iron. So in galvanization, we put the above layer like this of zinc. Okay. So if above layer is covered with the zinc, then the oxygen will not react with iron and the iron strength will be as same as that. So galvanization is the process of covering of zinc over the iron. Got it, everyone? Yes or no?
Okay.
Akasha,
But sir, zinc is more reactive than iron, sir.
It is reactive, but not like we know that oxygen, when zinc will be there, though strength of the iron will not be affected.
Oh,
The 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 strength of the iron should be remain same that we need. Okay.
okay.
Okay, so this is called as galvanization. So who will read? Eric will read. Eric, read this.
Okay. Galvanization. In this method, we put a layer of zinc metal on the iron objects, and this process is known as galvanization. This method is used on large scale for making galvanized iron sheets for making boxes and for roof covering. You might have seen large boxes and containers sold in the market. Do you know that these iron sheets do not rust even if small zinc coating is removed from the sheet? Can you find the reason why such sheets do not rust? Galvanized iron sheets are used to make drum, trunks, and other iron containers. Galvanized iron sheets are also used for building roofs and manhole covers. In brief, galvanization prevents rusting in a big way.
Yeah, and the fourth one is alloying. Now, what is alloying? Alloying is basically mixing of two or more metals. Mixing of two or more metals means when two or more metals like steel is made up of iron, cobalt, nickel. So they mix together to form another thing that will be strength, that will have strength also, and that will not rust also. So all the properties are there. That is what is alloying. Now you can't mix like you can take iron and you can take nickel and you mix it. No, you have to first make it to the molten state. Molten state we know, giving heat so much that the metal become liquid. Okay, then it will become molten state. So molten iron, molten nickel, and molten cobalt. When you will add it, then you can get steel in it. Got it, guys? So,
First,
uh, huh?
so we first melt all of those metals and then we mix them all together. So when they come back to the solid
Yeah,
state, they're all mixed.
mixed state.
Mixed it. So we first have to um so we have to first put molten iron and molten other metals all together.
Yeah. So in that's the meaning of alloying. That in this method, particularly metal with other metals or non-metals is mixed with a fixed proportion. You can't add 2 chammach iron, 2 chammach nickel like this. You can't put. Okay, you need in a fixed proportion to get the substance from the alloy. Everyone got it? Ira, sorry, David, Miraculin, you guys got it?
Yes. Yes, sir.
Okay. Read, Edric.
Alloying. This is a very good method for improving the quality of different metals. In this method, a particular metal with other metal or non-metal is mixed in a fixed proportion to improve its quality like resistance towards corrosion, strength, hardness, shining, and high.
Yeah, yeah.
What is it?
Which one? Resistance.
No. Shining and high dash strength. What is the TENSI?
Tensile.
Okay, tensile strength. For example, iron metal cannot be used for making utensils because it will rust, but when it is mixed with nickel and chromium metal, it becomes stainless steel. Now, it becomes very useful, and we are using the steel on a large scale for making kitchenwares and so many other things for our day-to-day uses. You just ask your father and mother about the carats of gold used for making the jewelry. You can also see that the purity in terms of karat printed on the back of any
Carat.
jewelry. You will see
So
that.
basically, we know that the stainless steel. Okay, that stainless steel is basically made up of what? Stainless steel is made up of iron and cobalt and nickel. That is useful because if only iron is there, then it won't be useful. Okay, if only iron is there, then it won't be useful because of the rusting and all the properties. But if you will add nickel and cobalt in it, you will get a good uh, strength metal or the vessel that we can use. Okay, now in the same way, the gold that we used to buy, it is like, for example, 24 karat, 28 karat, 22 karat, not 28 karat, 24 karat, 22 karat, 20 karat, 18 karat. So, okay, so that is basically the mixing of that is all is mixing of copper in it, or copper or other metal in it. Okay, so if 22 carat is there, then more copper is added into it. If 18 carat is there, then more copper is added into it. The 24 carat gold is the purest gold among all the 22, 20, 20 carat, 18 carat, all this. Got it?
What does carat mean?
Carat is the value. Yeah, or we can say it's the measurement.
Measurement of purity of gold.
Yeah, it's a measurement of knowing that how much gold is mixed and how much other metal like copper is mixed. Okay, got it, everyone?
Yes.
Now, thank you, David, for reminding one more time in message box that you have to do this homework. Okay, so Agatha, please put this uh, in our class group and saying thank you, David. Okay.
Just one problem. I don't know how to actually take a screenshot of this.
You just write in the group, na? Like homework
Yeah, I can
27.2
try.
the text question. That thing you have to write. And
Okay.
write thank you, David, also. Okay.
Why are you
Hi,
blaming
sir.
David all the time?
Because he always reminds me for the
No,
homework and all.
not you. It's a girl. It's Agatha.
What?
It's Agatha. It's not David.
No, but David reminds me, na.
No, Agatha reminded you that day, not David.
Before that, David messaged me personally that says we need homework like that.
But after Agatha came, you only came.
Yeah.
You were unstoppable.
So David
Okay.
did ask for homework.
He didn't. You did, but
Okay. Now we will run about reactivity series. Like we will read this because we did all this thing. So we have this reactivity series in your book also. Okay, that we learned in the past classes. Okay, so we will read this. Okay, so who will read? David, read this, please. Yes, David.
You have already seen that when iron is placed in a solution with CuSO4, it replaces Cu from the solution according to the following reaction.
Okay,
Fe,
why? Why, David? You tell me the answer. Why?
it is more reactive.
More reactive, more powerful than copper. That's why Fe displaces copper from its compound, making FeSO4 and Cu. Got it? Yes, Agatha. Making turn on the camera, please. Next, read the next part, please, David.
On the other hand, when we place silver wire in a solution of CuSO4, no reaction occurs because silver is less reactive than copper.
Means Ag and copper. Like Ag is less reactive, David. So Ag didn't displaces copper from its compound and everything remains same, hence no reaction. Did you understand? Everyone, guys. Drake. Got it? Okay. Yes.
sure. So now I got it that even sodium can be made pure from its salt solution by using potassium.
Yeah. Yes, David. Next part, please.
However, when a copper wire is dipped into AgNO3 solution, silver is replaced and deposited on copper wire. Reaction is as following.
And the answer is in front of us, which is that copper is more reactive than silver. Okay. So in general, a more reactive metal displaces less reactive metal from its salt solution that we learned in the previous class. Yes or no? Agatha, you have any problem, beta?
Sir, she's writing.
Agatha. Yeah.
By observing these reactions, we will say that Fe is more reactive than Cu and copper is more reactive than silver. If we take solution of different metals and place other metals in these solutions, we can compare the reactivity of metals with respect to each other. The arrangement of metals in the decreasing order of their activity is known as activity or reactivity series. It is known as electrochemical series. A
A
portion of
portion.
this series is given below. In this series, only few metals are shown.
Okay. So we have these reactivities that we have to learn. Okay, guys. We have to learn this. So this is important for our exam point of view. We have to learn this. Okay, mark it as we have to learn it. Okay. Okay. So now, any problem till now? Any problem, guys? Sir, I didn't understand this. Miraculin, Agatha, David, Edric, any problem?
No, sir.
No, no, sir.
Okay.
Just
Now
one
we
thing.
will
Can you
learn
write the notes pretty fast?
what notes, beta?
I mean, there are a few notes you have given here, right?
Hmm.
Can you just write them really fast?
I mean, I didn't get it. What are you saying?
Can I just write those notes that you have given here really fast?
Yeah. So okay. So then I will give 2 minutes. 2 minutes is enough.
Yes.
Yeah. 2 minutes, guys. You have quickly. If you want to write notes, or you can read it also. Okay. I will come at 10:35. Like I am here only at 10:35. I will start the thing again. But if you want to didn't understand anything, you can ask me also. Okay, done.
Yeah, so you can start.
Okay. Now, now we will learn about the minerals. So, if I will say this statement, Edric, that the soil has many minerals in it, what does this mean?
Huh? What, sir?
If I will say soil has many minerals in it, what does this mean?
Okay. So if soil has many minerals in it, like that means the roots can absorb the minerals from the soil and like send it to all other parts of the plant via the xylem.
And what are that minerals? You know, na essential minerals, non-essential minerals,
Macro
micro,
minerals,
macro.
macro, micro.
So
Yeah.
what are that? What are the macro?
Mg.
MgO.
Okay. No. It's nitrogen, phosphorus, and potassium.
Yeah, nitrogen, phosphorus, potassium. So basically, why I asked this question to turn on the camera? David, turn on the camera. Miracle, turn on the camera, please. So what is the meaning of that? That in our earth, there are millions of minerals are there. Million, not millions, millions too much. Matlab, like too much minerals are there. In a soil, too much minerals are there. For example, if I will take a magnet and if I will rub in the soil which is outside my compound, I will find it out that some iron particles will go and stuck to the magnet. Did you understand? So it means that iron mineral is there. That is why it is attracting towards the magnet. Okay. In the same way, there are many minerals are there in the compound. Okay, that is called as minerals. Minerals like all the metals, all the non-metals. These all are called as minerals. Now, if minerals are concentrated at one place, concentrated at one place. Miracle and David, turn on the camera, please. Concentrated at one place. For example, if you will go to the Jharkhand, okay, Jharkhand, that Jharkhand place, iron is concentrated. Like iron is find it like it's like lot of amount of iron is found in that soil. Do you understand, Agatha? Okay. If like for example, if outside my compound, sodium or not sodium, zinc is concentrated. What is concentrated? Zinc is concentrated. Okay. So that minerals concentrated at one place is called as ore. Ore. Okay. Like in Jharkhand, there is a iron mining is done. Okay. It means that the big chunk of ore is extracted from that place. It may be iron. Okay. And that iron ore, we use to extract iron from it so that we can use iron for the building structure and all. Got it, Agatha? No. See, in our soil, the iron will not present like somebody has digged the iron into it. No, it's not like that. We have to take out the ore, and that ore is impure. For that, we have to do some processes so that we can extract iron from it. So, the iron ore is basically the concentrated form of a mineral at one place. Got it? Okay. Now, the ore can be divided into three parts based on their reactivity. The ore can be divided into three parts based on their reactivity. First is ore of
Sir,
ore.
ore is a place.
Yeah.
Ore is a place in which a lot of minerals are deposited, right?
No, ore is
Ore.
ore is a like for example, when you will go for the iron mining, you will find it out the ore. So ore is basically the we can the substances from which we can extract the mineral from it. Okay, like ore is concentrated form of mineral. So if for example, if big chunk I extracted from the earth, that is ore, and from that ore we will get iron from it, like that.
A lot of minerals will be in one ore, so we have to extract the minerals separately.
Yeah. Okay. Okay. Now first is ore of high reactivity. Ore of high reactivity means high reactivity is there. For example, metal like sodium, potassium. These high reactivity. High reactivity we are getting from this thing. Okay. This is called as high reactivity. Okay. So if high reactivity metal is there, okay, then how we will extract it? We will extract it by the process of electrolysis. Electrolysis refining. What is this? We will learn in the coming part. By the help of electrolysis refining, we will extract high reactivity metal. Yeah.
So how do they mine uranium?
Uranium. Uranium is radioactive. There is another process of that.
Okay.
How
Okay.
did uranium come to this this reactivity series?
No, it's not there. Okay. Okay. And then after electrolytic refining, we get pure metal. We get pure metal. This is of if we get the ore of high reactivity thing. Did you get it, guys? No. Yes or no? Hello. Can you hear me? You
Yes,
got it?
Yes.
Okay. Now the third one is metal of low reactivity. Low reactivity like copper, okay, mercury. These all are low reactivity. So everyone please pay attention. When a metal have a low reactivity or comes in the bottom of the reactivity series, if you get the ore of this, it will always sulfide ore. Which ore? It will be always sulfide ore. Now what is sulfide ore? Sulfide ore is it has S and D behind. For example, copper sulfide, mercury sulfide, okay,
HGS. HGS.
HGN. So this will always have sulfide behind it. This is called as sulfide ore. Got it? No.
Yeah.
Okay. Now this sulfide ore is basically it's treated and it is called as roasting. Roasting. Okay. Now what is roasting? Roasting is heating in the presence of oxygen. We will learn all these things in the presence of oxygen. This is called as roasting. David, Agatha, Edric, Miracle, you got it, guys?
Yes. So
Mhm.
the roasting means presence of oxygen, but calcination means
Heating in the presence of oxygen. In the presence of oxygen. Okay. And after roasting, we will get the oxide of the metal, like oxide. We will get what? Oxide of the metal. Oxide of metal like CuS is there, then CuO we will get. This is called as oxide of metal. After roasting, we will get this. So it means that we have to remove the oxygen from it. And if you want to remove the oxygen from it, that process is called as reduction. So we have to reduce. We have to reduce the metal. We have to reduce the metal. Got it, guys? No.
So in the
Yeah.
first one, the ore of high reactivity, what is it? Something like that. Refining.
We will learn this. We will learn this in the coming
No,
chapter. We will learn everything.
I didn't understand. I
Electro
didn't understand what you wrote there.
electrolytic refining.
Okay.
And after when we get reducing, still we need a refining to get a pure metal. So reduce the metal, and we need refining, and we will get the pure metal. Then we will get pure metal. Guys, first listen in. Then I will give time to write. Agatha,
So-
David, don't write now, please.
So
Yeah.
first, metal of low react. Okay, so metals with low reaction like sulfur, like sulfide ore, are first roasted in the presence of oxygen. Then the oxygen from those metals are removed. And then what do you mean by reduce the metal?
Reduce no. When we will do roasting, we will get oxide like this in this form,
Okay.
CuO or AgO, like that.
So we get oxygen while roasting the metal.
Yeah. And after that, we have to reduce it so that oxygen can be removed.
Oh.
And after that,
And then
also
we
we
do
need
more
one
refining.
more process. In that also, we need one more process called as refining that we're gonna learn. After that, only we will get the pure metal.
Oh.
Okay. So, for example, if you get copper ore, okay. So, if you will get copper ore, you have to do all this step to get the pure metal.
Because the metals of high reactivity are mainly like magnetic, we can just use electricity to separate them. We make them.
They are not magnetic. Who said high reactivity like sodium, potassium? They are not magnetic.
Then what does it mean by electrodyne refining?
Electrolytic refining. Electrolytic refining, we will learn this, but for now, just like electro means electricity, lytic means breaking, refining means refining it. So with the help of electricity, we are refining it. That we will learn. No problem in that. Now don't write everyone. Guys, please listen to me. Okay. Now, if a ore of, for example, middle reactivity, the ore of middle reactivity. So the ore of middle reactivity, okay, it will be based. The ore of middle reactivity can be found in two ore. First is sulfide ore, and the second one is carbonate ore. First is sulfide ore, the second is carbonate ore. And just now we read the sulfide ore one. So David will tell me step by step. If you will get sulfide ore, what you have to do? First step is roasting. And after roasting, you will get oxide of
the metal.
Oxide of the metal. And if you will get oxide of metal, then what you have to do? Reducing the metal. Like oxygen is there, so you have to reduce it so that oxygen can be removed. So we will reduce the metal. And when we get the reduce of metal,
Then
we have to do the refining process. And after refining, we will get the pure metal. Got it? Yes or no? But now Agatha, please pay attention. If carbonate ore is there, for example, I will take zinc carbonate. Okay, everyone please pay attention. We will not do roasting. We will do calcination. What we will do? We will do calcination. Calcination means heating of ore in the absence of oxygen.
Yeah.
So everyone please pay attention.
Why-
Roasting is heating in the presence of oxygen, and calcination is in the absence of oxygen. Okay. And in the same way, if you will take out the like after calcination, we will get oxide of metal. Oxide of metal. And the oxide of metal, we have to do refining. No, reducing. Sorry. We have to do reducing. And after reducing, we have to refine it. And after refining, we will get the pure metal.
Sir, what is that heating of ore in the what of O2 dash
In the
O2?
negative of oxygen means in the absence of oxygen.
Minus.
Got it, everyone? No.
So okay, so so finding the sulfuric ore and the carbonate ore are quite similar, except the first step of sulfuric ore is roasted and the first step of carbonate ore is calcination.
Yeah. Everyone write it down. And tell me when you're done, beta. Edric, you're not writing, beta?
Already finished writing.
Huh?
I already finished writing.
That means you are
Yeah.
writing. That means you are writing in science teaching.
Yeah, Edric, you're not writing?
Oh, sir, I just got back from.
Sorry?
Sir, I was traveling today morning. I just got back.
Okay, okay. So in the next class, I need all the notes to be completed, Edric. Okay? Like on Monday.
Okay, from Monday onwards, I will complete the.
David, done?
No, sir.
Quickly write it down. And you guys have 4 minutes break, then come back in 4 minutes. Till then, David is writing. Miracle, are you writing na?
Yes, sir.
Write it down. Everyone has 4 minutes break. Come back in 4 minutes. Okay, guys, come back. So we learn about the all this oxide of metal. Yes or no? Now we will learn this. So we learn this just now. Hmm. So we learn this that ore is basically the concentration of ore, means the concentration of minerals. Now there are three types of reactivities are there. First is high reactivity. The second one is medium reactivity, and the third one is low reactivity. Okay, medium of low reactivity. Now in the high reactivity, we have to do electrolysis, means electrolytic refining, that we're gonna learn. Then pure metal. Now, if medium reactivity is there, two types of ore is there: carbonate ore and sulfide ore. Sulfide ore, carbonate ore, we have to do calcination, which is the heating in the absence of oxygen. Sulfide ore is the roasting. We have to do heating in the presence of oxygen. Then oxide of metal, then reduction, and then purification. That we learn. Now, metals of low reactivity, we get sulfide ore. That sulfide ore, we have to do roasting. Roasting, then we will get metal, and we have to do metal refining to get the pure metal. To get the pure metal. Did you understand, guys? Yes or no? Any problem? Miracle, are you there, beta? No?
Yes, sir, I'm here.
Yeah, no. I mean, you got it?
Yeah, sir, I'm good.
Okay. So now, Miracle, read this.
Understanding the activity series, you can broadly consider metals in three categories. Lower part of activity series, that is metal of low reactivity. The middle part of activity series, metals of medium reactivity. Top part of activity series, metal of high reactivity.
Yeah. So metals of high reactivity. Now read the next part.
Metals in the lower part of the activity series are very unreactive. For example, mercury, which is obtained as HGS,
Now
Cinnabar,
you have to
can,
remember this name. Remember this name. HGS is also called as Cinnabar. Cinnabar. So in the question in MCQ form, they can ask you that how cinnabar is extracted. Cinnabar is extracted by the process of roasting. Okay, because cinnabar has S, means HgS is there, means sulfide ore is there, and sulfide ore is extracted by the process of roasting. Got it, guys? Yes or no?
okay, sir.
Yeah.
Yeah.
Read this.
2HGS
Yeah.
So similarly, if we to know if a substance is carbonate, we just have to look in the end if it's CO3, right?
Yeah. Yes, Agatha. Correct. Carbonate is because of CO3, and sulfide is because of S. Got it? Yeah. Yeah. Read, Miracle. Miracle, read.
Yeah, 2HGS plus 3O2 heat 2HGOS plus 2SO2G.
So this is correct reaction in which, like I told you, like for example, everyone please pay attention. Don't read anything. For example, if I will take HgS, now it's a sulfide ore. I have to heat it in the presence of oxygen. Yes, and after heating it, I will get HgO, which is oxide of metal, plus sulfur dioxide gas will release. So this question can also be asked in roasting, which gas is releases? In roasting, sulfur dioxide gas is releases. Got it? Yes or no?
Yeah.
Okay.
Okay, sir.
And
Can you
when I will, yes,
can you repeat that?
the question they can ask is, in roasting, which gas is releases? So we know that
Okay.
roasting is done in the sulfide ore, S ore. Okay, that sulfide ore, when added with the oxygen, it will get sulfur dioxide. It is called as sulfur dioxide. So in roasting, sulfur dioxide gases releases. Okay. Now we got the oxide of the metal, which is HgO. We have to reduce it. So best reducing agent is that one, carbon. Carbon is the best reducing agent, which is also called as coke, like pure carbon. Okay, when you will take carbon into it, you will get Hg plus CO2 gas will release. Okay, means what carbon will do? Carbon will reduce others, means take oxygen from the HGO, making carbon dioxide. So best reducing agent is coke, means carbon.
Sir,
Okay, yes.
or can you use like instead of CO2, you can use CO.
Which
Carbon
part, beta?
monoxide. Instead of carbon dioxide, you can use carbon monoxide.
Carbon monoxide.
Yeah, carbon
No, we can't
monoxide.
take carbon. Carbon monoxide is very rare because of less the oxygen atom is there.
But for
So, but
zinc,
generally we get carbon dioxide only.
but for zinc, we get carbon monoxide.
Yeah. Everyone got it? So this is
Yeah.
how we got. Now this is still it's not pure metal. For that we have to do refining. What we have to do? Refining to get the pure mercury atom, and the refining part we will learn it in the coming part. Okay? Did you understand, guys? Yes or
Yes,
no?
sir. Yes,
Yeah,
sir.
read it now. On further heating.
On further heating, HgO is decomposed in mercury and oxygen. Two HgO heat 2Hg1 plus O2G.
Yeah.
Metals in the bottom of activity series like A- Ag and Au, etc.
Ag
are
silver
least.
and Au.
Okay.
Au is gold.
Silver and gold, etc., are least reactive and are found in native state. No doubt, some of them are also found in combined state. The metals in the middle of the activity series, such as iron, zinc, lead, etc., are moderately reactive. They are present usually as sulfide or carbonate in nature. Prior to reduction, these ores are converted into oxides as it is easy to reduce metal oxides. For example, in case of zinc, we get um, following reaction: roasting 2 zinc S or 3O2G. Heat
Yeah.
2 zinc. Yeah.
Yeah. So in the ZNS, we are seeing that Agatha, David, Miracle, turn on the camera. Agatha is there only. Okay. So ZNS, when in the presence of oxygen, we are heating, we are getting sulfur dioxide gas. Okay. And the zinc carbonate, same zinc is there. Okay. Carbonate ore is there this time. When it is heated in the absence of oxygen, here it is absence of oxygen. Like oxygen, we are not using. So we will get carbon dioxide as a gas release. Got it? Okay. So in the both the way we are getting oxide of metal, and then oxide of metal we will react with the reducing agent so that we will get the metal. Got it? Yes or no?
Got it,
Any
sir.
problem till now?
No, sir. Like I'm confused. Like what? I'm not getting the calcination. What is calcination? Like,
Calcination, like what is roasting? What is roasting?
uh,
Heating of
like heating of the metals.
in the presence of oxygen.
Yeah.
Okay. In the presence of oxygen is called as what? Roasting. Okay. Now, what is calcination? Heating of metals in the absence of oxygen.
Okay. Okay.
Okay. अभी बिल्ली गई है क्या? अभी तो नहीं था, मैंने झाड़ू लगा के बैठी हूँ।
मेरे को तो सबसे स्मेल आ रहा था।
अभी नहीं था, मैं झाड़ू लगा के सब कराया मैंने काम। अभी देख लिया मैंने। अंदर होगी बिल्ली जो अब निकली है जाके बाहर।
नहीं, कुछ नहीं देखा। Okay.
ऐसे साफ कर।
Okay. So what was I saying? That what was I saying?
Calcination.
Okay, calcination. Yeah. So now we can check this. Everyone, please pay attention. Now we are reacting this zinc with the zinc oxide with the carbon to get Zn plus CO gas will release. Okay, got it? Now Zn is reduced to zinc. You are already familiar with the process of oxidation and reduction. Obtaining metal from their compounds is always reduction process. We also displays reaction of the reduction of metal oxide. For example, Fe2O3, aluminium, FeAl2O3. These all are basically thermite process. Now we will learn about the thermite process and we will end today class here only because I have to go somewhere else. But we will see the video of thermite process also. Okay. So basically what is thermite process? Like for example, if there is a crack, if there is any crack in the railway crack, railway track, okay, like for example this is a railway track and there is a crack, so we will not do that. We will take Fevicol and we will paste iron into it. We can't do this. Okay, so we have to go for a thermite process. Now what is thermite process? Thermite process is basically the oxide is reduced in the presence of higher reactivity metal to get this. Now everyone please pay attention. Then what happened? We take a powder of Fe2O3, which is iron oxide, and we heat this powder in the presence of aluminium. Now aluminium comes above the table, so aluminium will displace iron from its compound like Fe2O3. Okay, when it is react with the presence of aluminium, so aluminium comes above, so aluminium will displace iron from its compound making Al2O3, which is ash, plus Fe iron will be placed in the crack. So this is how, this is called as thermite reaction. Now what is thermite reaction? It's a reaction in which iron railway tracks is fixed on the basis of the this thing. Got it everyone? No, you didn't get it.
No, sir.
See, when railway track is cracked, okay, we use this iron oxide powder, we placed it, and we heat this solution with heat this salt in the presence of aluminium. Now aluminium is higher reactivity, like it's come above the iron, so aluminium will displace iron from its compound making Al2O3. Okay, and iron will stick to the railway track, hence all the things will become normal. Got it?
So, so when a railway track cracks, you put this Fe2O3 in the crack and then add aluminium to it. The reaction would be that Fe would remain, but Al2O3 would be removed.
In the form of powder.
Okay.
Okay, and this is how the metal like railway tracks is fixed. Okay,
And this is called the thermite process.
Thermite process, yes. Heating of the iron oxide metal in the presence of aluminium. Okay.
So heating of iron oxide metal in presence of aluminium is known as thermite process.
Yeah.
So, I wanted to show something. I painted my friend's shoes.
Huh?
What happened?
So I painted the shoes.
Oh, wow! David! David? David?
Yeah.
Have you taken painting as one of your subjects?
No.
Oh, so then what is your fifth subject?
There's a subject called painting. You should have taken it.
Then what is your fifth subject?
Math, science, accounts, English, and data entry.
Oh, data entry. Oh, same as me, bro. Same as me, exact 5.
Okay, so guys, we will complete this part as soon as possible so that we can leave the class because I have to go out. Okay, so now I told you the top reactivity series.
Yeah.
So for example, the top reactivity series like sodium. Sodium we can't found in the ideal state because sodium is highly reactive. So the atmospheric oxygen which is present, it will directly react to it. Okay, so sodium will never found in the ore form, but it is found in a compound form. The question can be asked from the examiner that why sodium is not found in the ore form. The sodium is not found in the ore form because of its highly reactivity nature. It can react with oxygen. Okay, it can react with oxygen and it will blast. Okay, so that is why it is found in compound form. Now, for example, Na is found in a NaCl form. NaCl, which is the desh ka namak, Tata namak. Okay, this NaCl salt, if I want to extract Na from it, then what will I do? Electrolytic refining. Now, electrolytic refining means I will first heat it till the molten state. I will heat it till the molten state. Okay, this NaCl, I will heat it till the molten state. Okay, for example, this is NaCl molten state. No water in it. Okay, only the molten state of NaCl. Okay, now in the molten state, Na and Cl, they will the ions will form. Like NaCl is there. Okay, in the molten state, it will become Na plus and Cl minus. The ions will form in the molten state. Okay, now what will I do? Now I will take two two what do you say electrode. First is anode and the second one is cathode. First is cathode, like for example the plus, this is called as anode and this is called as cathode. So anode are the positively terminal electrode and cathode are negatively terminal electrode. Now if I will pass the electric current through it, so the Na plus is there, it will move towards the cathode part like this. Okay, and Cl will deposit at anode part like this. So in cathode, we will get the deposition in cathode, we will get the deposition of Na plus to get one electron, and Na, sodium will deposit at cathode. Sodium will deposit at cathode. In the same way, anode, chlorine minus will be there. Chlorine will be deposit at anode. Got it? Yes or no? You didn't understand? Agatha, David, Miraculin, Edric, you got it?
Yes.
Okay,
Yes.
so we have to heat the salt in order to, well, get it in its molten.
State. Yeah. Okay.
So what do you mean that salt cannot be in its it is not a sulfide or a carbonate, carbonate ore or sulfide ore.
The higher reactivity metal.
Yeah.
The higher reactivity metal will not found in carbonate ore and sulfide ore. Why? Because of the higher reactivity. They can simply react with oxygen present in the atmosphere. Like if you will take Na and just put it into the water, it will react. Okay, so they are highly reactivity towards the oxygen. That's why they are found in NaCl form, like sodium chloride form, so that we can extract Na from it.
Because if it's just Na, we would keep loosen our salt.
Yeah. Write it down quickly.
We lost that screen.
Did you do the?
Oh my God, why?
We can just look back in the video, right?
I clicked
No, you
photos
can't
just
see now.
before.
I mean, we can look back in the video. I mean, you will search this video on YouTube, right? So you can just look back at it and then look
Yeah,
at
you
this.
can check in YouTube. You can check in YouTube. Why it happens? I don't know.
just finished clicking the photos before sir removed it.
Okay, now everyone, we will see this video of thermite reaction. So in this, there's a mixture of iron. In this, it is a mixture of iron oxide, Fe2O3, and aluminium. Okay, and we are just heating with the help of this burner. Okay, so that we will get iron which is molded in the railway track form, and aluminium oxide which is the salt which we get from it. So the iron will be stick to the railway track. Got it, guys? Got it? Yes or no?
Yes, sir.
Yes.
And they put a machine over there to put the iron in its place or something, right?
Yes. It's like a molding part. Okay? Yes or no? Any problem in today's class, guys?
So
No?
one problem.
Yes.
So you gave homework.
You tell me to give. That's why
Sir,
I always listen to my students.
Sir, fine. If you always listen, then no homework from Monday to Wednesday.
Then why you message me?